talk about. So welcome back. Our next speaker is Luis. He's a Microsoft MVP. So Luis, thank you for joining.
Oh, nearly there. He's not
Almost there.
Yet. No, wasn't the best timing.
No. So Luis is going to talk about how you can fine-tune an Azure Open AI model. And he's going to share some lessons learned when fine-tuning it.
This is another, I'm excited for this talk actually. Fine-tuning is one of these ones, like when do you add data, when do you fine-tune? Here he is, he's here to answer all these questions for us.
Hi Luis, welcome.
Hello everyone. It's a pleasure to be here. I have been listening to all the sessions by the great speakers, and it has been great to learn about semantic kernel, about OpenAI, generative AI. I was impressed by the music session. Wow.
Wasn't it interesting? I was going to say, for anyone watching on demand, go check out the music and audio session. It was a great one. I had like 1,000 questions, felt a little bit embarrassed at the end, if anything, just hogging the question stream.
But you're going to add some interesting content on top of that, right? About fine-tuning.
Sorry?
You are going to add a lot of interesting content to that.
Hopefully it is interesting for everyone. There are some experiences that we would like to share when we had to do it for some customers, also for some MVPs. So yeah, it was interesting how this works and what, let's say, other things we can do to customize some model and get the answer that we want from these powerful models.
Good. So for those who don't know you yet, can you do a short introduction?
Yes, of course. I am a Microsoft MVP in AI and developer technologies. I am from Mexico, though currently I am living in Czech Republic because of work, because of studies. And well, I have some experience as a .NET developer with .NET MAUI, cloud applications, and of course, AI. This is an interesting world.
Wow, sounds good. Sounds like a lot of experience. Are you ready?
Thank you. Yes, I am ready. So I'm about to share my screen. Thank you very much. I appreciate it. Okay, so here it is. Let me know if you can see my screen.
Yes, we can see it.
Okay, perfect. So let's get started. Thank you everyone who is joining to this session. I hope that it is great for you. So let me know in the comments. Also, I will join, of course, Discord after if you want to chat. So yeah, our sessions is about some lessons about some experience that we acquire while fine-tuning, customizing some open AI models. So yeah, I already introduced myself, and at the end I will share a link where we can connect and continue talking about this. So I will not spoil, of course, the lessons in the agenda, so stay tuned, of course. So very first, brief introduction about what is fine-tuning for the ones who, let's say, don't know, or it's the first time that hear about this topic. Then 4 lessons that we found out while doing this, maybe some tips, some recommendations, although in every lesson we will also share some experience, some ideas. At the end, some Q&A from you, from the audience. And yeah, that would be basically all. All right, so let's get started here. What is fine-tuning? So fine-tuning is a way of applying transfer learning, a technique that uses knowledge which was gained from solving one problem and apply it to a new but related similar problem. The idea is that you take one model which already has some knowledge because it has been trained, but it focuses on one task. Then you customize it, you tune it, you tweak it. Let's say you replace maybe the last layer of your neural network, and it will perform a second similar task, maybe some generalization, right? Or maybe you want to set it up for your own classes. And yeah, and as I said, this is very typical in transfer learning, and it is used because maybe we don't have the enough power computation for training huge models, but we can reduce, let's say, training time and also the cost and, of course, the resources that we need to create a derived, let's say, model from it, from the knowledge that it already has. Of course, GPT-3 is a state-of-art language model developed by OpenAI, and it has the ability to generate human-like text, complete tasks such as translation, summarization, and of course, create original content. However, as powerful as GPT-3 models are, it can struggle to perform optimally on specific tasks or even on specific industries, let's say, to work with your own data. These models are really good, or they perform really nice at answering questions when the answer is contained within the paragraph. However, if the answer isn't contained, the base models tend to try to do their best to answer anyway, which in turn leads to hallucination, right? To some answers that we might think that, yeah, it is just trying to guess. To solve this and to augment GPT-3 capabilities, we can use fine-tuning or embeddings and other techniques, completions API, or even rely on other technologies such as Azure Search to create Q&A assistants and solve other tasks like recommendations, for example. Fine-tuning is needed for domain-specific use cases to increase the accuracy for specific implementations in terms of, let's say, very specific jargon to some industry, to industry-specific terms, let's say information about company products, services, and so. And it relies on few-shot learning by training on many more examples that can fit, let's say, in the prompt. So you achieve better results on a wide number of tasks. Once a model has been fine-tuned, you won't need to provide more examples because, let's say, it already understands how to solve or answer the questions. And there are some models that currently can be trained, such as GPT 3.5 Turbo, Babbage, and DaVinci. These are the 3 steps that you need, basically 3: prepare and upload your data. Of course, you can apply some pre-processing if you have raw data from a database, an API, some file, right? Then train and deploy the model, which is the fine-tuning process. This might take some time. And after that, use your custom new model for chat completion, for example. Here, you can pause the video or just follow me on Dev2 platform. My most recent publications are about how to fine-tune an Azure Open AI model using OpenAI Studio on one side, and second one, a C# language. So yeah, you can grab the code or the instructions there. So I will not do this step by step because you can follow the blog post, but I will talk that for every step, let's say in the first one, which is about preparation and uploading your data, this is how you will teach GPT-3 what you would like it to say. In fine-tuning, every training example generally consists of 3 elements, which are the behavior, the input, and the output. And you bring this through system, user, and assistant roles. You can see, or if you have worked with the API, you might be familiar with the role and content pairs, let's say for one of the messages, right? And well, this is, even though, let's say, we can see several lines, actually these are 2 lines. One is, let's say, that this first element, and this is a second one. Each of them are part of a JSON-L or JSON lines file. You need to create 2 files, let's say one for training and second for validation, that consist of these elements. So yeah, a messages object inside a JSON. Then this messages is an array consisting of these pairs of role and content. And you typically will provide the three, right? System, user, and assistant for the output, the input, and also the behavior. Once you get this, then you upload them by using the API or some SDK, or of course, AI Studio, OpenAI Studio. So you upload both training and validation. Well, training is mandatory, validation is optional, but if you provide it, you can, of course, compare it later to improve, let's say, accuracy. Then you just train or click, let's say, on some button to start a training job, or you can submit it using the SDK, right? You need to wait, so and because it takes time. And after it is successful, this task, then of course you need to deploy it if you are using Azure Open AI. So yeah, then this process deployment also takes time. It needs to be hosted on the Azure cloud, right? So then you wait, and after it is available or this task is successful, then you can use it again in your program that you write using Python, C# or whatever, or also in the AI Studio. So I will exactly do that. I already have, as you can see, a model here. It is already trained. It is, of course, already deployed, which is yeah, this one, basic GPT 3.5 Turbo. This is sorry, no, it is the second one, this global AI custom model. And I already have an example here just to save time, right? So I can just copy this. And you can see that I already selected my deployment, oh, sorry, and also provided a system message, right? So if I just send here or click here, the idea is that it extracts or it grabs the ingredients from some text, right? So it was trained to understand this. So this might sound, let's say, as very good, right? So we already tested this. However, there are some, let's say, issues once that you start trying it. The first one is that you are not teaching a model new things by fine-tuning, because we might believe that fine-tuning is meant to bring more data into a model, like teaching new things, but this is incorrect. The fine-tuning process actually is intended to help a model recognize new patterns and respond to these patterns appropriately. So you are not teaching it new stuff. And yeah, this is, let's say, very crucial to understand. So it is pattern recognition rather than generating, let's say, a new knowledge. In the past, I trained a model that understands, let's say, news from two categories, let's say baseball and hockey. However, when I ask something outside, apparently, of the scope, like this message, Cristiano Ronaldo and Messi are two soccer players, I was amazed that it brought this result, soccer. I did not train, right, or I did not fine tune my model to bring this output. So then I asked in the forum, and yeah, I got a response that basically with fine tuning, we are adding, let's say, some bias through a specific class, but the OpenAI models do not, or the GPT models do not forget what they already know. It already has some knowledge about, okay, this text belongs to soccer category or so. In, let's say, normal or the usual classification or training, right? When we decide or specify classes, and if we provide an unknown or different example, it will typically say, okay, it belongs to this class, although, of course, we know that it is an error. But in this case, it brings, let's say, the correct one, but I did not, let's say, expect that. This would be a nice example of what we can use fine-tuning for. Let's say that we have or we receive emails from different curriculum bits from people, And of course, these are unstructured data. They do not follow some pattern. They are quite different, right? They can write it in the text, or they can have it inside a PDF. So what we can do is to find a model that understands, okay, this is the first name, this is the last name, this is the email, right? And then we provide this data to our trained model, and we can bring it to, let's say, we want to create some structured version of all this data. So yeah, this would be a good example of what we can use it for. Another example would be for sentiment analysis. Of course, the typical negative, positive, or neutral. But what if we would like to create something more complex? Like we would like, okay, this one is maybe 2 negative or 1 star. Then another one is 2 star. Maybe we can consider it as low negative, maybe neutral. Then positive and super positive, for example, right? That we can create our own. So yeah, that's possible. This was our first lesson. Second one, use embeddings to teach GPT new data. You can actually increase, expand the knowledge of the GPT models by using these techniques. Yes, so GPT excels at answering questions, but only on topics it remembers from its training data, because training data for GPT 3.5 Turbo, GPT-4 mostly ends around September 2021, the models cannot answer questions about more recent events, such as, let's say, the Olympics from 2022. If we ask this kind of question, like which athlete won the gold medal in curling at 2022 Winter Olympics, it might tell us, okay, I'm sorry, I do not know, because it is a recent event, or it is in the future. My knowledge stops at some date, right? So, and of course, this also happens for other unfamiliar topics, such as non-public documents, your documents, information from past conversation, and others. So the question is, how can I put more data into these models to expand the knowledge for other purposes? One option that you have is called semantic search, which essentially allows you to take in a corpus of text data. Maybe you have tons of PDFs, books, or legal documents. You can take that corpus of text data, put it through a specific function that vectorizes all the information. You can apply some pre-process it. It maybe chops it up, chunks it up, and put it into some multidimensional vectoring system. So it sorts of tags what the content of these different chunks of data is, and then it remembers for later. We can improve this process by storing it into a database, and this is a similarity database. Then we will be able to prompt the model, the GPT models, the original ones, when we put it, our input in it, so it will bring the relevant, let's say, information. It, of course, will also vectorize our question, right? So it compares vectors to vectors, let's say. And after that, it will decode the vector into the data that we as users expect, which is text, right? And text that is coherent and also precise, of course, if we provide factual information. This is also known as the two-step search and ask method, and it enables GPT to answer questions using a library of reference text. And well, this is just basically embeddings, and we have heard from it in some past sessions. Embedding is an information-dense representation of the semantic meaning of a piece of text. It measures how related are two text strings. And basically, these vectors of floating point numbers calculate the distance between two embeddings in the vector space. Here you can see two dimensions. However, you can imagine that there are a lot of attributes. There are a lot of things that we can compare to strings too. So this typically is multidimensional, right? But yeah, the idea is that if they are closer, it means that the two texts are quite similar. And embeddings are commonly used for search, clustering, recommendations. It can even use for anomaly detection and classification. These are the steps that you will need for this, let's say, technique. Again, it's kind of similar to the other one. However, here you do not train a model. Actually, the idea is that you will bring or you will add into the let's say text that you are asking the relevant information, so it knows the answer, or it will know how to find the answer within the provided text. Okay, so there are 3 steps: prepare your search data, search, and then ask. So okay, first step, prepare search data. So you collect it from database, from some API, from some file that you already have. So this is, let's say, the relevant code. Then the second one is chunk, basically data cleaning, right? So if we have HTML, we can remove tags, we can remove white spaces, you know, this, let's say, from other machine learning tasks, right? So you pre-process your data because in the end, the sections or the information should be large enough to contain enough information, but we also want to, let's say, clean it. We want to avoid, let's say, some trash or information that is not helpful at all. Then we apply the embeddings. OpenAI has some, how to call it, functions, right? Or we can call an API that vectorizes the information. Or let's say this is done by every document, right? Yeah, so we can create this embedding vector, and then we save it.
Luis for a bit. I think something went wrong with the connection. Let's hope he will join again soon.
It was a great part of the talk, to be
It
fair.
is.
The comparing of fine-tuning versus adding extra data, and like they're not really the same thing was kind of where I'd got to on interpretation of that one. So hopefully that was what he was trying to portray. But it's yeah, it's a great, he gave some great examples of like when would you fine tune, why would you fine tune versus yeah, the adding your own data element, adding your own data, you're looking to say, hey, this is actually the real, this is the information, like take that first and then go to the LLM, or but then calling out that fine tuning was, although obviously it will cost to fine tune a model, you're technically putting less into your prompts potentially. Like if you're prompting LLMs to be so specific, your prompts are going to get super long. That's always definitely something to take into account. Like at what point is there a trade-off, I guess, isn't there, between the two?
Yeah, and that is very difficult. And also, I think for most people, it is undoable to start fine-tuning these models, right? So you need very specific knowledge around that.
Yeah, no, definitely. I was going to say, and even just finding his learnings and challenges is a good insight into kind of what is, yeah, when to do what and what has he learned from actually doing that in some senses. So fantastic. I think we might not be getting Lewis back. So we might be. Hold for just 1 second. You know, it's like live streams. They're up and down. When they're up, they're great, right? They're giving you lots of information. I don't know how many people are sort of side watching. This is definite second screen watching, isn't it? Like whilst you're doing your work and then be like, oh, fine tune it.
Hello.
Yeah, he's
I'm
back.
sorry, my connection dropped.
Oh.
I'm very sorry for this.
No,
No
don't worry
worries.
at all. It happens. We were just saying, like, live streams, right? The only thing you can't control is your internet, I think, most of the time. So
We tried to finish your session, but it was a bit impossible for us. So we're glad that you're back.
yeah. So
Okay.
feel free to jump in and carry on. We'd love to hear the end. We were getting excited about those learnings.
Yeah.
Yes, of course. Yes, I will wrap it up. I am sharing my screen, so let me know if you can see it.
Amazing. Just give
Hopefully.
us 1 second there.
Yes.
There we go.
It is
Carry
there.
on.
Okay, awesome. Thank you. Thank you. I'm sorry for this. Then, okay, so we store the embeddings, then we create some function to search. So provided some string, it will be converted into the embeddings. Then the idea is that, yeah, we will just rank the embeddings by similarity with the input, the question that we ask, and we will get, let's say, the top 5, top 3. It depends on how much information we actually want. And finally, we will just ask. So basically, we create some function. We can provide the input, right? We, of course, if we are using the OpenAI SDK or or send a REST call, we will just need to format it. So we provide system role, system message, right, for the assistant, for the user, and we expect, of course, the assistant, and we get the GPT's answer. And we can test it. I have it here, right? So basically, I can share in the end the code for it. So the idea is that here we can test it. So if we ask our original questions, which athletes won the gold medal in curling, now it will know, right? Because the idea is that we already got some data, and yeah, it will now know the answer by creating all these embeddings. So yeah, it is cool. So then we already tested this. Now let's say, there are, let's like some comparison. GPT can learn knowledge by model weights, that is fine tuning, and also the model inputs. However, yeah, as you can see, it is more recommended with embeddings, but it is a starting point for your own system. It also has different purposes. So you don't get ChatGPT-like answers with fine-tuning. Basically, ChatGPT is the application and GPT is the brain behind the application. When we fine-tune a model, we interact with the API, and it is not the same as when we interact with ChatGPT. And you saw it in the past. The idea is in fine-tuning, you get some content, some structure, some pattern, right? But with the embeddings, for example, we use completion, so you get a text like in a conversation, right? So that's also some difference. And the fourth one and the last one is that fine-tuning can be expensive. Yeah, unfortunately, the reason for the high cost of hosting a fine-tuned model is because of the complexity of the model and the resources required to run it. You can do the math, but here you can see that training one GPT 3.5 turbo model for 1 hour costs you $102. And then it needs to be hosted, so you can later request or ask some questions to it. And it costs $7 per hour. So you can do the math and know how much it costs for 1 day, for example. So do you really need it, right? Or can you use embeddings instead? So here you can see the cost for embeddings, right? Not even 1 cent for every 1,000 tokens. So yeah, you can see that the cost is quite diverse, right? Fine-tuning also involves training on large data sets to improve the accuracy. So yeah, this is the reason. So some tips to wrap it up, because we are on time. So first one is, do you really need fine-tuning? Consider embeddings. They are cheaper, they are faster, they can learn new things. Prepare your data carefully, of course, to also avoid cost. choose the right model that you will use for embeddings or fine-tuning if you would do it. If you are going to choose this way, okay, don't bring your 1 million data. Bring some stages, let's say some partial data, maybe 100 or 1,000 documents. Then you can improve. You can see what's the behavior. Maybe you do not need to bring all these 1 million examples, only a small portion of it. Evaluate, test, monitor, and update regularly. But always keep in mind that these models are still in infancy, so it is far from perfect. It delivers robust solution, but it still has room for improvement to grow. Sam Altman said that it is impressive, but it still has some weaknesses. So it doesn't have really true intelligence because it analyzes text, right? And it can be biased. It can be fooled into creating incorrect racist content that we, of course, do not want. All right, so this is the end of my presentation. Maybe just some resources to keep learning. Here I share some resources from OpenAI documentations, the cookbook, and also the Azure Open AI documentation. This is for fine-tuning, and we have something similar for embeddings. And with that, I close my presentation. So thank you very much for your attention. Sorry for the issues, and let's connect. I share my link here where you can find me. And of course, I will join Discord afterwards. Thank you.
Thanks. Really great. So
thank you. I appreciate it.
Thank you so much for joining us. We need to get into the next speaker.
Of course.
Thanks a lot. Have a great day.
Enjoy the rest of the event. Thank you very much. See you and
bye-bye. So our next session, we have two speakers for that one, Alexander and Said, and they will combine AI with the metaverse. So looking forward to it.